All right, so number 15, what do we got? Okay, it's the question of the basketball. We're given the equation. Okay, and I'm going to quickly graph it or sketch it really. I know that the y-axis is the h because usually the y is alone on the left side of the equation. And so that means the x-axis, sorry, it's not y, it's h and d. So that's like the first thing. Next, I'm going to graph my parabola. I know it's upside down because the a is negative. Here's the question. Is the ball going to start on the ground? So at this point here, I don't know the height, but what is the distance at this point? Right here. What's the distance, folks? 0. So if I sub in 0, what's 0.09 times 0? 0. 0.9 times 0, 0. So what's left? It's just going to be a 2, right? So that's just like a really quick way to figure out the y-intercept. Okay, but I'm going to take that down because maybe we need to actually find it. But I'm like, okay, I already know there's going to be a y-intercept. And it's going to go somewhere like that. Great. We are told that both units are measured in meters. First, what is the maximum height reached by the ball? Layla, which tool am I going to use to find the maximum height? You got it. Right? And folks, I hope you have a summary page or like a cheat sheet that you're going to review right before the test. And on it, it says, if I need to find the max height, I'm going to complete the square. That's the tool. So I start off by just writing out the equation in standard form. Okay, review of completing the square. Draw square brackets around the 2D terms. Factor out the coefficient of d squared. So that means I'm dividing everything by that coefficient. And so I get d squared, and then, is it 10? Yeah, so it's going to be minus 10. Now go ahead and find what that other number is. So take the coefficient of b, divide it by 2, and square it. If I was power. Sorry, I need to go find my power bar. Can everyone finish completing the square there? I don't know. Oh, here it is. Okay, sorry about that. Okay, so I took negative 10, divided by 2, squared it to get 25, right? That's my side work. So I go plus 25 minus 25. Now, I factor the perfect square trinomial, 0.09, and the orange becomes d minus 5. I'd encourage you not to just copy it, because just watch, just watch and take that out, right? Don't copy. I think you're going to be better just watching and understanding what I'm doing. Do you know what I mean? Because you can copy it later. It's going to be available. I don't know. I'm just, all right. So once I've done this, I have to get rid of the square brackets. And then I'm going to multiply 0.09 times 25. It's 2.25, so plus 2.25 plus 2. Miss Sly, how did you get that? I'm happy to explain. Okay, once I have it in vertex form, I've got my vertex. And folks, I'm very visual, so I put that information right back on my picture. It's like, oh, my vertex is 4.25. So it's 4.25 up, right? But it took 5 seconds. So question A says max height. So we'll say, okay, max height is 4.25 meters. What's question B say? Now this is weird. I generally like to put question A and B in one question because it feels weird to do question B when you have no work to do. Question B says, at what horizontal distance is the ball from the player when it reaches the max height? They're saying, what's that distance? How far did it travel horizontally to get to the max height? And it's just B is 5 meters. That's it. There's no work to do. So I would prefer on a test to say, what is the max height? And at what horizontal distance did it happen? I put it in one question so that you're not thinking, I got to do some math, but I don't know what. Does that make sense? Okay, good. And then question C. There is no question C. That's it. All right, so that's question 15. Let's look at question 16. Any questions about 15? All right, go ahead and read 16. Read it and draw a picture. This one's a bit weird. Luckily, they give us a picture. Both are in meters. Now, this is the weird thing. The ground is in the negative H's. So the bridge has two posts, right? The green is the ground. The bridge has two posts, and then it has this. Here, I'm going to make the ground a bit more solid, right? That's the ground. And then it's a cable bridge. So there's a cable going from the tip of one post to another tip. And because the cable is hanging, because of gravity, it makes a parabola. Do we understand the picture? So our vertex is going to have a positive D value, but a negative H. Okay, question 1. What is the vertical distance from the top of a support tower to the lowest point on the cable? What they're saying is, whoa, what is that distance? So to find that distance, I need to find the vertex. Question B says, what is the length of the main span? This is question B. They're saying, how far is it all the way across? Question C. At a horizontal distance of 50 meters from one end of the cable, how far is the cable below the top of the support tower? So question C is saying, hey, let's say there's a random point here at 50 meters. How much lower is the cable from that point? Okay, so that's our question C. So starting with question A, it doesn't say it really clearly, but because we're looking for the vertex, we're going to complete the square. So let's all complete the square. And one of the questions I got from one student or many students in this class is, are we going to have these ugly decimals on the test? And the answer is yes, you will. So I know it's like, ick, I wish they weren't there. Just go with it. It's going to look ugly. It might not make sense until the end, but just push through. All right, so go ahead and complete the square on this one. Oh gosh, this is ugly. Oops, I forgot to put a D behind the D. As you're watching this, you might have some questions. Please ask. And this is when I take the perfect square. It's a perfect square trinomial. So I'm going to factor it. Square root of D squared is D. The square root of 57,600 goes here. And that's going to be 240. Yeah. Yeah. So I did this ugly number divided by the common factor. Did you get a different number? Did anyone else get a different number? Anyone else get 480? Yeah, okay. Maybe you missed a zero there. Oh, good. Okay. And then the final step where we're going to multiply each of these by the common factor. Okay, so 57,600 times 0.0008 is going to be negative 46.08. And that means I have my vertex. And I'm like, ooh, one component, the h of my vertex is negative? I must have made a mistake. Miss Sly, go to the picture. Go check your picture. Okay, I'll do that. Oh, yeah. In the picture, the vertex is below the d-axis. So that means that my vertex has to have a negative h value, right? It's 240 meter across, and it's negative 46.08 from the d. So when the question asks, what is the vertical distance from the top to the lowest point? Well, the vertical distance is 46 meters, 46.08 meters. Looking at the picture, I'm asked for the horizontal span between the two towers. Do I know how to find it very easily? Yeah, I can double 240 because I know that the vertex is right in the middle. Okay, but let's say I don't know that for sure. How can I find the horizontal distance? Okay, watch this. And folks, I'm going to put this on my memory aid. I am going to find two x's. And how am I going to do it? I'm either going to factor or I'm going to use the quad formula. Right? This is, again, I need to find the span, the range, the horizontal distance. Ding, ding. Find the roots. Use quadratic formula or factoring. And it's going to look like we want to use the quadratic formula because of the decimals, but actually that would make our lives much more difficult. So we're going to factor out that 0008. We're just going to factor out the common factor. So this is greatest common factor, which is 0.0008D. And when I divide each term by that, I'm left with D minus, I think, 480. Yeah, 480. And I'm like, man, I would really like to use the ZPP at this point, the zero product property. I wonder if I can. Well, what is the height at this horizontal distance? It's 0 because I'm literally on the d-axis. Okay, so I can use the zero product property, and I get, okay, D equals 0 and D equals 480. So at the two tips of the tower, those are my x-intercepts. And I find out that my x-intercepts are 0 and 480. Oh, so my bridge is 480 meters wide. Right, so my span, therefore, the span of the bridge is 480 meters. Question C.
Can you not just double the x-intercept?
You could, but if I tell you to do it algebraically, this is how you do it. Okay? And I will tell you to do it algebraically. So you won't get full marks if you just double it, but you'll get some marks. Okay. Question C. They're saying 50 meters from one end. Okay. So 50 meters from one end. Now I know 50 is going to be about here. How deep does it go? So if I know the D equals 50, do you know what I do? I actually don't know what to do, but I'm going to listen to what Miss Epper-Jesse once told me. She said, when in doubt, substitute. Where could I substitute H equals 50? Y into the equation. Oh, interesting. So H equals my D is 50. So anywhere that I have 50 in the equation, anywhere that I have a D in the equation, I substitute 50 in there. And what am I going to find? Well, I'll find the H. I'll find the height. And that's what they're asking me to do. So I'm going to punch all of this into my calculator and do it in one go. See if you can do that too. Oh, gross. I got a negative number. Oh no, did I make a mistake? I don't think so. And that's because we are being asked how far down is that cable, right? So I'm like, oh, at 50 meters, it's 17 meters below the D axis. So we can say cable is 17.2 meters below top of tower. Okay, so I'm making a recording of this, so I will post this if you want to rewatch it. For the rest of the lesson, you can come to me with homework questions. You can work on the practice test, and I did post the solution